Alright, so the Archimedes style pulley system, which is here, and let's watch really quick the video about it.
There's a type of pulley system we haven't talked about yet. It's a compound pulley system. You remember the block and tackle? We had an 8-to-1 mechanical advantage. Well, this has the same mechanical advantage, but it does it a different way. You remember we add up the tension on these ropes and we have 1 plus 1 is equal to 2, but if we have 2 plus 2 is equal to 4 and 4 plus 4 is equal to 8, we can come up with an 8-to-1 mechanical advantage just like that with less pulleys. This is fascinating, and one of the first...
Alright, so that shows you a demonstration and how it all works. And so it's 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16. So we got 4 pulleys make 16x. So we're going to want a few more to reach 32, 64, 128, etc. So we're going to want to probably go 6, 2, 4, 8, 16, 32, 64. 64 to 1 should be perfect, I think. So we'll use 6 pulleys for most of our designs for 64 to 1 mechanical advantage. And one concern people have is, what about friction? So as the string passes through the tubing, there's some friction there, I agree. But the tubing itself is Teflon tubing, which is a very low friction plastic. And so the string will not have that much friction on it. But there is some. And so for that, you coat the ends of it with Teflon grease or Teflon lubricant, which will get inside here and even reduce the friction more. And the same with these. You'll want to just put on the outside, and as the string pulls through, it'll lube the inside of the tubing. So you'll get a lot more lubrication, which will reduce friction. And that's the best we can do as far as reducing friction. But I want to bring up something where I think a lot of people haven't considered. What if, in some cases, the friction is actually a good thing? So basically, in order to have holding power, I was saying it like this. Imagine you're trying to pull somebody up a mountainside on a rope toward yourself. So you're standing at the top of a cliff and somebody's on the side of the mountain. You're trying to pull them in. In between pulling, you want to rest, right? Well, if you wanted to rest, it would help if you wrapped the rope around a tree once or twice and then went down to that. So when you pull and then you rest, the friction of the tree kind of holds on their weight, so you don't have to strain as much while resting in between pulling. So basically, if there's a decent amount of friction in the system, the amount of energy required by the motor to hold a position, which is what the majority of the time the motor is doing, it's just holding a fixed position. Like if I pick up a weight, there's an initial burst of energy to lift up the weight, but then I'm just holding it there. And the strength required to hold it is less if there's more friction in the system. And so having the pulleys have a decent amount of friction means the motor actually will burn less energy holding a position after it's reached its desired ending position. It'll need less exertion to hold it there. The downside is that initial pulling before it reaches its desired position requires more amps, more power to do it, because it's working against the friction works against it. But once it reaches its desired position, the friction helps it. If you could turn up the friction somehow, you'd want to do that. You want as much friction as possible once you reach your desired final state, because then the motor just wants to chill and relax and rest, catch a breather, and have the friction of the system hold the item in place. And since the majority, as I said, of the time in a human body, you're just wanting to hold positions, then the friction, the majority of the time, is helping you. And it only works against you in the rare case that you're trying to move. But most of the time, you're just holding a position. So the friction may be more power efficient on the battery system overall because there's a decent amount of friction there, because it helps with all the holding situations, which is the majority of the time for the majority of the muscles. And so the downside, the trade-off, is it's harder for the initial movement phase, but on the holding a position phase, it helps you. And the amount it helps you might more than make up for the resistance it gives you during the movement phase of it. And so it might balance out. It might neutralize each other. And it might be not a big deal at all. So there's pros and cons to friction in the system. As a general rule, yes, we want to reduce friction, which can be seen as waste. But the fact that the friction helps us to hold positions, and we want to hold positions often, it's almost like you almost want the friction there. It might actually work out to be better than where there hardly any friction at all, which is shocking to think about, but that could very well be the case. So that's a cool thing to think about, and through testing that might bear out, or you might not even know how to calculate that. It might remain a mystery, but that's just one way to think about it, where you can be like, the friction is actually not such an enemy as we thought, potentially. But it might remain a mystery. I don't know. It's just something interesting to think about for sure.